Some more inequality fun. Yes. 2.3, solving inequalities using multiplication or division. Another pretty simple and quick lesson. But let's make sure you really got it. Go through, try all these warm-up problems. Let's get it rolling. All right, go for it. So you can see that these are solving equations, at least the first three. So hopefully you saw that you needed to get g by itself, which means you need to divide by 6, right? Because then if you're dividing by 6 or multiplying by 1/6, 6 divided by 6 is 1. Any number divided by itself is 1. So we get 3, and we can obviously plug back into check. 6 times 3 is 18. That equals 18. Check, check. Okay, hopefully you saw this one. We needed to multiply both sides by 6. The inverse operation of division is multiplication. And whatever you do to one side, you do to the other. And you got 12. And then 12 divided by 6 is 2. Does that equal what we have on the other side? Yes, it does. Check, check. And then here, what did you do? Hopefully you divided both sides by 8. You got -7. And 8 times -7 is our magic number of -56. Okay, here we're simplifying these expressions. Remember, grouping symbols include absolute values, so you'd want to take the absolute values first. So this would become 13, and then 13. So this becomes 13 minus 13, which you know is 0. And again, you would start with order of operations. So you would look inside the grouping symbols, do that work. What's -10 divided by 5? -2. The absolute value of that is 2. And then we would take, looks like that negative sign got kind of squished in there. That's weird. Oh no, it's minus and then absolute value -2, which is going to be -2. Good. Our learning target is that you will be able to use division to solve an inequality and will remember to always flip the inequality when you multiply or divide by a negative. That is the only difference in solving these inequalities as compared to equations. When you multiply or divide by a negative, not what you're dividing into is negative, but when you divide by a negative or multiply by a negative to both sides, you flip that inequality sign. Okay, feel free to go find someone or work with your invisible friend. You don't need to copy the table, but you do need to complete it and then decide which graph represents the solution of these two down here. Let's fill in this first. So I'll do one with you as an example. Oh, they have an example here. So they're telling us x is -1. What would 3 times -1 be? -3. Is 6 less than 3 times -3, which is -9? Absolutely not. Okay, so try the others. Pick the graph, and then come back. All right, so hopefully you ended up getting 0 and no, 3 and no, 2 and no, sorry, 6 and no, 9 and yes. Notice here how 9 is greater than 6, or 6 is less than 9. And going from there, you would have gotten that. Okay, so which of these two graphs would work? Where are those numbers that are solutions? It's where x is what? 3, 4, 5. So which one is that? This one right here, yes. This one, yay. Now notice, we're just picking the integers, right? 2, 3, 4, 5, 1, 0, -1, right? Of course, anything in between here would also work. So if we use 3.5, 3.5 times 3 would be 10.5. Is 6 less than 10.5? Yeah, it is. So it's all real numbers there. It's not just the integers. Okay, part B. Use a table to solve. You pick one of the inequalities below. Then write a rule that describes how to use division to solve the inequality. So pick one of these two, do a table, tell us what the rule is. And I'm not going to show the table I made, but what's the rule? Hopefully you came up with when you divide both sides by the x's coefficient, in this case 2, in this case 3, the golden rule strikes again. Awesome. Okay. Now, Try the same thing here, but this time we're going to have a little bit of a difference because instead of x and negative 3x, it's, before it was x and 3x, now it's x and negative 3x. So go ahead and do the same thing and then pick your graph. So you got 15 and yes. Oops. That's not what we wanted to do. Everyone makes mistakes. It happens. Still here on beautiful Lake Norman. Still enjoying my vacation. But what's better than vacation? Than vacation with a little math. Oh yeah. So which one of these would work? Where are we going to find those? Yeah, where we get to negative 3, negative 4, negative 5, the x values, right? So what would we describe this graph as? X is less than negative 2. Okay, so go ahead and try B while I have some fun circling this one. Yay. And do those, and then let's come up with the rule. Now be careful here. Careful here. Hopefully you got x is greater than negative 2. And negative 2 is less than or equal to x. What's the rule? That if you divide both sides of the inequalities by x's coefficient, but you have to flip the inequality of dividing by the negative, right? Just think about it. Like if I use the negative 5 and I plug in here, is 6 less than negative 3 times negative 5? Is it less than 15? Yes, it is. But in order to solve, if I was solving that, I'd have to flip the inequality to make it stay true. Okay. All right, so we're going to divide this into two parts, just like we had to kind of work with a visible friend there. Multiplying and dividing properties and division properties of inequality when c is greater than 0. In other words, when what we are multiplying or dividing both sides is a positive number, okay? When it's a positive number. So here, if we have negative 6 less than 8, true statement, right? If we multiply both sides by 2, then we'd have negative 12 is less than 16. Is there any need to flip the inequality there? Is that still a true statement? Absolutely. Here, if I divide by 2, I had 6 is greater than negative 8. Isn't 3 greater than negative 4? Totally fine. Okay, don't need to flip. Notice we're not multiplying or dividing by a negative. We're multiplying or dividing by a positive. C is greater than 0. Okay, and then here, basically, it's same thing. This is an algebra. If we have A is greater than B and C is greater than 0, then if we divide both sides by C, A over C is going to be greater than B over C. Okay, and same thing for if it's at A is less than B. Doesn't matter. Okay, if you're dividing by positive and C is greater than 0, then we're good. By the way, why can't it be C is equal to 0? Think about it. If I had 5 is less than 6, and I multiply by 0, and I multiply by whoa, hello, where did that come from? If I multiply by 0 here, are these equal? Is one less than the other side? No, they're both 0, right? So 0 would equal 0. So that doesn't work. I mean, this is a true statement. 0 does equal 0, but it's changing what we had here. It's not equivalent. It's not equivalent. Okay. So, and then same thing for division here. Can you divide by 0? If C was 0, can you divide by 0? No, it's undefined. Okay. So that would basically take your inequality and turn it into nothing. It's undefined. Okay. So let's solve some of these. So this is n divided by 7. So what would you do to both sides? You would multiply by 7, right? Good. Am I multiplying by a positive number to both sides? Yeah, I don't need to flip the sign. I get n is greater than or equal to negative 7. Okay, so let's go and graph it. Okay, what's our key point? Is it open or closed? Is it going left or right? Hopefully you realize that it is key point of negative 7. It's a closed dot, meaning we're including negative 7 in the solution set. And where are the numbers that are greater than that? To the right. And by the way, plug it in. What's negative 7 divided by 7? Is it our magic number that's on the other side? Yes, it is. It's negative 1. Awesome. Okay, here, what are you going to do to get W isolated? Or in other words, to get 1W? Hopefully you said divide by 15 to both sides. 15 divided by 15 cancels. 7.5 divided by 15. Hopefully you recognize that is the same as 1/2, or 0.5. And then go and graph it. Key point, open or closed, left or right. Careful with this one. Okay, good. Key point's 1/2, closed circle, and we want numbers that are smaller than 1/2 or equal to it, so it's to the left. Okay, try this one. When you divide by 1.5, hopefully you can see that 3 goes into 18 6 times, so it goes into negative 18 negative 6 times, and then 1.5 is going to go in double that many times, so it's negative 12. Okay, key point, open or closed, figure out whether it's left or right, and hopefully you got that it's going to the left. We want numbers, our solution set are numbers that are less than negative 12. Those are to the left on the number line. Okay, the only difference here is now what we are multiplying or dividing both sides by is less than 0. In other words, it's a negative, right? And let's look at some of these numbers examples just to kind of illustrate this further. Negative 6 less than 8. If I multiply both sides by negative 2, so my c in this case is a negative, negative 2. Well, what's negative 2 times negative 6? It's 12, right? What's 8 times negative 2? Negative 16. If I left the inequality sign the same way, would that make sense? Would it make sense that 12 is less than negative 16? Of course not. So you have to flip the switch to make it true. So you have to flip the inequality. I call that flipping the switch. Okay. Same here. Divide both sides by negative 2. Well, I'd have negative 3 and I'd have 4. It wouldn't make sense for the inequality to stay the same. Negative 3 is not greater than 4. Not on Earth, not on Mars, not even on Uranus. All right, so in algebra, again, same thing. If we multiply both sides by a negative, because remember, c is less than 0, so we're multiplying a times c, and over here we're multiplying b times c. You have to flip that inequality, okay? Same thing with division, okay? And again, it doesn't matter if it's greater than or less than, greater than or equal to, less than or equal to. If you multiply or divide by a negative, flip the switch. Simple as that. All right. So here's 4 of those problems. Try and catch those. See if you can get the ones. I'm telling you right here, right now, 3 of these you need to flip the switch. 1 of them you don't. Go for it. Okay, so hopefully on that one you multiply both sides by negative 4. You got to flip that sign. And I would do that first. Do it right away so you don't forget, because that's where people make that mistake. And then we're going to graph this. Key point, negative 28. Open circle to the right. Okay. On this one, hopefully you divided both sides by negative 9. You got negative 7. By the way, checking it, negative 9 times negative 7 is 63. Is that our same magic number? Yep, means we have the right key point. And now it's all up to our graphing. By the way, did we flip the switch? Of course we did. We did that first. Open and then to the left. All right, let's go up here to this one. Here you're going to divide by 0.4. Okay? And did you flip the switch on this one? Notice what I did. I moved the decimal place over for the numerator and the denominator. Get rid of the decimal. 120 divided by 4, yep, is negative 30. Did you flip the switch? I hope not. Did we multiply or divide by a negative? No. We don't care about what we are dividing into. Okay? We care what we are dividing by. And what we're dividing by here is a positive. So we get y is greater than or equal to negative 30, which should be a filled in dot, arrow to the right, key point, negative 30. And obviously this one you're going to divide by -2, flip that switch, don't forget. A lot of times I like to go alert, alert, alert. Got to remember to flip that switch. Key point is 11. Close dot, arrow to the left. Awesome. All right, you're working a summer job, $9.50 per hour. That's actually not allowed here. It's below minimum wage. Actually, I don't know about here in Lake Norman, but at home, I know it's more than that. My daughter worked at Gelato Angels on Manhattan Beach Boulevard near the Manhattan Beach Pier this summer. She was getting $12 an hour plus tips. But then the employee took away their tips. They like wouldn't allow like the credit card to ask for a tip. Evil. Anyway, she lived. It's all right. So anyway, $9.50 per hour. And you want to assign and define a variable. You need to write and solve an inequality that represents the numbers of hours you need to work to buy a digital camera that costs $247. Okay? So could you work more than what makes 247? Of course, right? So again, it's going to be an inequality. So what's unknown? What's our unknown here? Yeah, it's the numbers of hours. So I used H. Okay, you could use X, knock yourself out, whatever variable you want. H equals the number of hours. Okay, so what goes into making this $247 or more, right? It's your what times your what? It's your rate of pay times the number of hours that you work for that rate of pay, right? So what's our rate of pay? $9.50 times H has got to be greater than or equal to $247. Okay, and now it's off to the races, right? Divide both sides by 9.5. I'll do that math for you. How nice. Greater than or equal to 26. So what would our answer be? No naked numbers. What would it be? At least 26 hours. There's lots of different ways you could say it. You could say 26 hours or more, something like that. All right. Okay. You have at most $3.65 to make copies. Each copy costs 25 cents. Assign and define a variable. Write and solve an inequality that represents the numbers of copies you can make. Okay, so what variable should we? I'm gonna go with C. What do you think? Did I go with C or with N for number? Let's see. I went with C. Okay. So what would your equation be? Again, think about, or inequality, excuse me. Think about what goes into that 365. It's the number of copies times the cost per copy. So hopefully you had 0.25, if you did this in dollars, times C would need to be what? In this case, you have at most $3.65 to make copies. So it would be less than or equal to 3.65. Okay, then what do you do to solve this? You're going to divide by 0.25, which is kind of like multiplying by 4. You get 14.6. So what's your answer going to be? How many copies can you make? If you go to Starbucks, can you ask for half of a cup of coffee? What are they going to do if you do that? Or if you ask for 6/10 of a cup of coffee? They'd even look at you even more crazy than if you just ask for half. Yeah, you can't get a half. Can you get 0.6 of a copy? Of course not. So what's your answer? At most 14 copies. Okay, again, so you got to use your common sense. We're answering real life questions here. Okay, and I think we got one more to go. We do. All right, the maximum speed for a school bus is 55 miles per hour. Sure hope so. Probably shouldn't even be that fast. The way some of these drivers drive. Write and solve an inequality that represents the number of hours it takes to travel 165 miles in a school bus. And here we go, back to our distance equals rate times time. Okay, what are we trying to solve for? The number of hours it takes to travel, the number of hours, right? So I'm going to use my variable, H, for number of hours. Okay? And what goes into traveling 165? Your rate times your time. In this case, our rate is 55. Our time is H. So 55 times H needs to be bigger than or equal to 165, right? Divide by 55, and you get an answer of at least 3 hours, right? All right. That does it for that. Yes, this unit will get more challenging, but that's good. Challenge is a good thing. We're going to learn some things that you probably knew most of this, if not all of this, but we'll get into some new stuff soon. All right, enjoy.